Okay, we are going to start to get into some of the nuts and bolts of actual object-oriented programming, which is what Java was designed for. And we're going to start that just really, really simply by creating some methods uh, within our main class. We're not going to create our own classes yet. Remember, in Java, and we talked a little bit about object-oriented programming at the end of last semester in Python. So you should know this vocabulary of classes and methods. And we've been kind of glossing over it so far, but it's time to get serious about it. Your program in Java is a class, and your code lives in a method of that class called main. We're going to create some other methods inside our program class that are going to behave pretty much identically to the way functions did in Python. But because Java requires a little more, as the one source I refer to as plumbing, it's a little more complicated, or it looks a little more complicated, but it's really not. So the idea I had for this really, really simple method is, suppose we want to calculate the properties of circles and spheres. Circle has, if we give it a radius, which is all I've done in my main program here, is define one variable called radius. I can have the radius of a circle. With the radius of a circle, I can calculate the circumference and the area. Circumference is 2 pi r. Area is pi r squared. I could also consider that to be the radius of a sphere. I can calculate the surface area of a sphere, which is 4 pi r squared. Or I can calculate the volume of a sphere, which is 4/3 pi r cubed. Let's write functions, or in the vocabulary of Java, methods to our main program that actually do these calculations. So I'm just pasting a little comment here. We're creating methods to calculate the area of a circle. We'll start with the area, then we'll make it more complicated. Well, actually, let's add area and circumference of a circle, and the surface area and volume of a sphere. And we'll change this to methods, plural. Okay. So how do we start? We start by defining a method. And this is the syntax we need. We need to tell Java a little bit about what kind of method it is. Just like when we declare our main method, we have to use all this gobbledygook: public, static, void, main, and then some arguments. We have to do the same thing for the methods that we create. So we're creating a public method, we're creating a static method. The method is going to return a double, it's going to return a decimal value when I call it, and it's going to be given a argument, a parameter, that's a double decimal number called radius. Okay? So all this does is tell Java what kind of method we are creating. We're creating a public static method that returns a double, and then it's given one parameter, a double called r. What do all these things mean? I'm going to link to a video explaining kind of the vocabulary of public versus private, static versus not static. But basically, public means that your method can be accessed from anywhere in the program, including the methods of other classes can run this method, or you can even call it from inside a library that's outside your program can call this method. So you can think of the public as just saying, I can run the method from anywhere in the code, as opposed to a private method, which can only be called by the class itself or an instance of that class. For most of what we're doing, it's fine to keep our methods public. If you want to know why you would ever want a method to be private, to be only callable from inside the object itself, we'll look at that in a couple of weeks when we get to real honest-to-goodness object-oriented programming. Declaring a method as static means that it belongs to the class, not to a particular instance of the class or a particular object of the class. The reason when we create our main, it's a static method, is because your main program doesn't have a separate instance of itself that calls that, or sorry, your my program class doesn't have an instance of itself that calls that method. That method just belongs to the class itself. It's, again, complicated until you see why you would ever, or it's confusing, not complicated. You just put the word static in there. It's confusing until you understand what the alternative is. And again, we don't really know what the alternative is to a static method until we actually are creating our own classes and objects. So for now, it's just one of these things we put at the beginning of our method declaration, and we will figure out what it quote unquote means when we start doing real object-oriented programming. We're writing methods that return a value, so you call the method and it gives you some result back. And so we have to tell Java what kind of value it returns. So our syntax is public, static, and then what we're returning, in this case a double, then the name of the method, and then inside the parentheses, any parameters or arguments we'll be giving the method when we call it. So in this example, we will give the method a radius, and it will return the circumference or the area or the volume of that object. So that's the idea. So here's our method. And I'll go ahead and comment this. Method to calculate the area of a circle. Okay. What's the area of a circle? It's just pi r squared. So all my method is going to do is I give it r, and it's going to return pi. I could type 3.1415, whatever, but there's a pi built into the math library, so I can just write math.pi. I think some of you discovered this when you did your math grab bag assignment a couple of weeks ago. And I won't use the math power, it's just r squared, so I'll just type math.pi times r times r. I could also do this in 2 steps. I could do something like result equals pi r squared, and then return result. That doesn't really make it simpler in my mind. Why not just compute it right there in the return? But we can do it this way. It's fine. Either way, it's fine. Oh, except I didn't declare result. So I guess I'll have to declare result as a double. Okay? Now this isn't going to do anything when I run it. Why? It ran. It doesn't do anything because what does my program do? It creates a double call to radius. It has a method called area that calculates the area, but it doesn't actually call that method. In order to make something happen, I've got to call that method. So I've got to, and I'll just do it in the print statement. I'll just say, I'm going to copy and paste this so you don't have to watch me laboriously type. System out print, the area of a circle with radius, whatever my radius is, 1, is, and then I call my method, area, parameter, radius. Whatever my radius is gets passed to my area method as an argument. Okay. Again, I could do this. I could say double area equals area radius. Or what do I want to call this? Computed area, to distinguish that from the name of the method. Computed area equals area radius, and print out computed area. I could do it in 2 steps. But again, that doesn't really make anything simpler. I can just call it in my print statement, but we'll do it that way for now. The area of a circle with radius 1 is 3.14 159,265. That's right, right? The area is pi r squared. If r is 1, it's pi times 1 times 1, which is the answer we just got. Okay. If my radius is 10, okay, I change my radius variable to 10, run the program. I should get 100 times pi, right? 314.159. So this works. Let's do it again for the circumference. So we'll do that. We'll just copy this whole method. And we'll create a new method called circumference. It still takes a double precision floating point decimal, and I don't have to use a different variable name because this parameter is local to that method. What we call the scope of that parameter is local to the method where it's declared, so we don't have to worry about the computer being confused by there being two variables called r, one here and one here. This r in this method, the variables in this method don't know anything about the variables in that method, so I can call them both r and it won't cause any problems. I can call these both result and it won't cause any problems because again these variables are local to the method where they're created. I should change this word to circumference. My comment. And what is the circumference of a circle? It's 2 times pi times r. Oops, r. Okay, so the circumference of a circle is 2 pi r. Let's compute that. Again, I'm copying and pasting, so I don't have to type quite as much. We'll call this value computed circumference. And then we call the circumference method with the parameter of the radius, whatever our radius is. Add a little space in here. In fact, let me add a bunch of space down here. So now I'm looking at the bottom of your screens. And then we print out the computed circumference. So system out print line, the circumference of a circle with radius r is computed circumference. So computed circumference is just a temporary variable to hold the result of calling that method. Circumference is a big word to type. Oops. Okay, so let's run it again. Make sure we didn't make any mistakes. There's a pretty good chance I missed a semicolon somewhere just from typing too fast. No. The circumference of a circle with a radius of 10 is 62.8. Is that right? 2 times pi times 10. Yeah, that's right. 2 times pi, 3.14. 2 times that's 6.28. Times 10 is 62.8. Good. Okay. Let's just, to get in the habit of writing these methods, let's do two more. Let's do it for a sphere. What do we compute for a sphere? We compute the surface area, and we can compute the volume. So let's create a new method. Okay, up here. Public static double, let's call it surface area. And it still accepts that same input, that same argument or parameter to the method. And this is a method to calculate the surface area of a sphere. That's the begin, that's the end. And if you want to be really fussy with your comments like I am sometimes, we can comment this, end of area method. Really not necessary when your method's only 2 lines, but when your methods are more than a screen long and you're scrolling through your code and it's hard to tell where one begins and one ends, might not be a bad idea. And this is the end of the surface area method. One of the reasons I do this is, I know I talk a lot about the fact that I learned how to program in the 1980s and 1990s. IDEs in the 1980s and 1990s were just big text documents. You couldn't do fancy stuff like this. You guys can click on these little triangles and collapse your methods so you don't have to see all that code. When your code gets really, really big, you can make it look simpler by collapsing little bits of it. We couldn't do that in the 80s and 90s. We didn't have these fancy IDEs that let you collapse little bits of your code like that. So we had to do it the hard way by marking the beginnings and ends ourselves when we're scrolling through it, so it's easier to see. I'm going to pop these back open again. Maybe you didn't know you could do that, so we learned something. So where's our method? It's here. We've got, again, a double that we're going to call result. And that's equal to, what's the surface area? There shouldn't be an equal here. The surface area of a sphere is 4 pi r squared. I'm just going to copy this from up here. And it's 4 times that. And then I'm going to return the result. Copy that from here. And then let's just go ahead and do the volume at the same time we're doing this. Right? So there's our surface area method. I'm going to just copy it and duplicate it here. And I'm going to do the same thing for the volume of a sphere. I'm going to call it volume. It still accepts the radius of the parameter. I'll change this word to volume. Okay, and got to change this word to volume too. What is the volume of a sphere? It's 4 divided by 3 times pi times r cubed. And again, I'm going to be lazy. Instead of using the cube function built into the math library, I'm just going to go r times r times r. Okay. 4/3 pi r cubed. Return the result of that calculation. So now I've got 4 methods: volume, surface area, circumference, and area. Let's now call them. I'll call it computed surface equals surface area given the parameter of our radius, and double volume, computed volume is equal to, call the volume method with our radius. And I missed a semicolon there. And now I just need to print out those results. So I'll copy my print statement twice. The surface area of a sphere with radius is, I think I called it computed surface. And then the volume of a sphere with radius plus radius is computed volume. Okay, and that O shouldn't be capitalized. See if I made any mistakes. Uh-oh. Just a semicolon. Line 51. Where's that? Oh, right there. Is that the only one? Line 56? Yep, both of them. Run. The area of a circle with radius 10 is 314. The circumference is 62.8. The surface area is 1256. The volume is 4188.79. Okay, so it seems like that works. Those seem like reasonable numbers to me. So when creating a method in Java that's just part of your main program, it's really no different than creating what we called functions in Python, except that I think in Python we might not have had to declare what kind of variable the function was going to return. It's been so long since I programmed in Python, I've flushed it all out of my brain. Now it's all full of Java. But Java, we have to tell it what kind of variable to expect as an argument, or variables to expect as an argument, and what kind of variable it's going to be returned, and I have to tell it that up front. I have to tell it who's allowed to access it and what kind of object it's going to be associated with. So that's the basics of methods. What we'll do in the next two examples of code is I'm just going to go back to some of the programs we've done already. I'm going to go back to maybe some of the prime number programs, maybe the Project Euler programs, and just rewrite them to use a method instead of just having everything live inside the main method of the code. So that's what we'll do next.